Welcome sa Material. In this video lesson, we will be investigating what is illustrating linear inequalities in two variables all about. Okay, let's get started. And we have to start it word by word. The word linear. What does it mean? So when we say linear, actually we are focusing on this kind of equation. But now, this was your lesson previously in the previous quarter, but today we will now go to different contexts. Though the concept of linear is in the idea of linear inequalities, this is an algebraic expression that involves the raised to the first power, and basically you can always see the combination of two variables and the exponent is always 1. Unlike to the quadratic, this one, for example, x to the power of 2 plus 3y, this is not linear. So that's the idea first term here. And now, if we talk about inequality, basically there are four inequalities or four relational symbols. The word inequality is there. These are the four inequality symbol: the greater than, the less than, greater than or equal to, and this is equal. And sometimes we can see not equal symbol in the inequalities. And we have to show the relationship. That's why the name is relational symbols. For example, 2x plus 3y less than 10 is a linear inequality. Okay, that's the idea there. And if we talk about two variables, we are actually referring to the concept of two unknowns. And they can be represented or they can be any two letters or symbols. The goal is to satisfy the given inequality. Now, to give you an example of the two variables, again the goal is to satisfy the inequality. To give you an example, it's a 3x plus 2y greater than or equal to 6. Basically, the 3x and 2y are linear expression involving two variables, the x and the y. And greater than or equal to is the inequality symbol, or sometimes known as relational symbols, indicating that the greater than or equal to, and 6 is the constant on the right side of the inequality. And if you will want to satisfy the inequality, you have to find variables that set the x and y or satisfy the inequality itself, often represented by shaded region or graph or range of possible solutions. And that's the purpose of the next slide. Okay, this linear inequality is two variables. There are a lot of methods in showing this in graphing form, and I have here 7 steps in graphing. Okay, these are the 7 steps, and the method focusing on these steps is graphing the linear inequalities into variables. Okay, we'll illustrate here the 7 steps, and this is basically the graph of linear inequalities into variables. And step number 1, identify the inequality. There are 4 cases that you can see that this is linear inequality. Again, ax plus by less than c, ax plus by greater than c, ax plus by greater than or equal to c, and ax plus by greater than or equal to c. The third is less than or equal, the fourth is greater than or equal, where a and b and c are constants. So here's the second step, graph the corresponding line. Basically, you have to review your linear equation concepts because that's the first consideration in graphing the linear inequality. This is the first form, ax plus by equals c. In graphing the line here is this in the color blue. To do so, solve for using the slope-intercept form. Okay, that's the step number 2. Step number 3, you have to consider its relational symbol, and it should satisfy the given inequality. For example, for greater than or equal, you have to use the dash line to represent the boundary and the shaded region on or below or above the line respectively. And what I mean here is this one. If it is less than, you have to graph like this and the shaded region on the left side. And if it is greater than, you have to graph on the right side and you have to draw the boundary line, which is broken line or the dash line. That's for the greater than or equal. And for the greater than or equal to or greater than or equal, the blue here can be represented by this graph. Now it is a solid line below, above, or on the respective line. And for the greater than or equal, we have here the right side shaded and the solid line as its boundary line. Okay, now let's proceed to step number 4. Step 4, we have to test the point. In testing the point, I will show you the idea here. Notice that we have two kinds of, or two points here, the 5, 3 and the 5, 1. The 5, 1 does not satisfy the equation because 8 is not equal to 12. That's why it's not included on the shaded area. 5, 3 does satisfy the inequalities. Inequality given here that x plus 3y greater than 12. So as long as it satisfies, it is true to all that 14 is greater to 12, it is part of the solution. And if it's not equal, it should not be included on the shaded region, like 5 and 1, specifically on x plus 3y greater than 12. Okay? In step number 5, we have to label the shaded area. So here's the idea here. As soon as you have put the boundary line, which is dashed line because it is greater than, we have to shade the shaded area and label it as this one greater than. So it is greater than, therefore we have to shade on the right side. Okay. Now let's have step number 6. We have to repeat the 5-step process in order for us to get another answer if we have more than 2 overlapping inequalities. Basically, we have given this kind of inequality at first, and afterwards you have to do the system of linear inequalities, and it will be given by 2 inequalities. And notice that that's step number 6. Step number 7, we have a shaded region here. And this is the next lesson that we are going to discuss, which is more on the linear inequalities in 2 variables in the system. This is a system already. Shaded region here is the overlapping region where the 2 inequalities overlaps. And remember, the importance of this lesson is you can solve the optimization problem where the particular inequalities is important to visualize the visible region and the importance of the problem of optimization. This is the one of the method. This is an example of the answered system of linear inequalities. The solution is overlapping here. And the second example, and the third example. That's it. Thank you so much for watching and listening. I hope you learned something in this